right. So where we left off, we did go over that this answer to this one um oops, sorry, was a change in distance over a specific amount of time. That is the definition of speed. So we're going to move forward. And you can see that distance divided by time is the formula for speed. We're going to need to use this as we discussed in class. And you will see it written like this: distance divided by time. You'll even see me abbreviate it d divided by t. S equals d divided by t. You can see in the formula triangle that at times you might have to find time and distance. So this first one is speed, and you do distance divided by time. You can see it's written here. For this one of time, if we're ever asked, if you're ever given a distance and a speed, you're going to need to find time. And time is distance divided by speed. If you ever are given a time and a speed, you're going to need to find distance, and that's distance equals speed times time. Okay, so this is a good page to bookmark, maybe even screenshot, save it somewhere. It's a really good one to have. So moving forward, speed units. I did tell you in sixth grade, we're more than likely going to use meters per second, which is the second one of M/S, because we can test out meters and seconds. It's kind of hard for us to do miles per hour or kilometers per hour. But when you're doing practice problems, we might use miles per hour, which is MPH. You guys are even familiar with that when you see speed signs around town when your parents are driving. Kilometers per hour, which is km/h. So these are some units of measurement for speed, okay? Remember that speed incorporates both distance and time. So you have a distance and a time, you have a distance and a time, and you have a distance and a time. Average speed. Well, here's a practice problem. Okay. So it says a baseball is thrown a distance of 60 feet. So we could write with our pen, we could write down the things we know. We know distance is 60. And then we know that seconds is time. So we know time is 0.5. Perfect. And we know that this is feet, and then this is seconds. Okay. So we know distance and time. It asks you what's the speed, or it could say how fast is the ball. So we're going to do distance divided by time, which is the formula right here, just written backwards in this one. So we know we do 60 feet divided by 0.5 seconds. And we can get out our calculator and we can type in 60 divided by 0.5, and that's 120. Make sure you type it in right. Okay. And that is 120. And you need to have the right units of measurement. Remember, it's speed, it has a distance per time. So feet per second. Okay. And that's that one. How do I get out of there? All right, there we go. So now that you pretty much know the formulas, we can apply it to any practice problem ahead of us. But for average speed, this is another good slide to bookmark, to screenshot something. Um, you're not only gonna have to find speed off practice problems, but you're gonna have to find speed off of graphs coming up. You're gonna have to read the graphs and find the speed. And this is where kids find calculating speed challenging. Okay. So this is a typical graph. We know the point of origin is at 0. You have to be aware that on the bottom, you're going to have time, which is the x-axis. On the y-axis, you're going to have distance, which is, in this example, it's meters. So we have seconds and meters, time and distance. When you have a graph that has a line like this is showing you a constant speed, okay? Slow constant speed. It's kind of at that angle, and you can see like for every second, where you have a distance of about 10, okay? This is when it's straight across, no stationary speed. So you can see that over the course of like 1 second, 2 seconds, 3 seconds, the distance stayed the same. So pretty much they're at rest. Like what they were doing, I don't know. But this is just straight line, no speed, nothing. Okay. When you have a big old slope that's almost like straight up, but it's kind of sort of off to an angle, um, the steeper the line, the greater the speed. Okay. So it even says here, the steeper the line, the greater the speed. So we have another constant speed, but it's faster than this one because the line is steeper. Okay. So again, this is like like a little cheat sheet for graphing when we get to it. All right. So how can you calculate speed? Well, I think a lot of you know it's going to be distance divided by time again. Okay. And I'm just moving that back. So moving forward for average speed. Average speed, it's an average of all speeds over a given time. So again, what is the unit for speed? A lot of the times it can be meters per second when we're using in 6th grade science. So if you want to type that in, go for it. Average speed formula. So when we find average speed, we're looking for a total distance and a total time. Okay, total distance, total time. Same thing as the speed formula, distance divided by time, but now we're getting the total distance and the total time. So we'll do a practice problem coming up. So again, average speed, they put the formula at the top, total distance divided by total time for average speed. So while on vacation, Jose traveled 400 miles in 8 hours. What was his average speed? So again, you just set it up like we did before, okay? So it tells you a total of 400 miles, that's your distance, in 8 hours, that's your time. So we have distance and we have time. So we divide the two. So again, if I open up the calculator and type in 400 divided by 8 equals 50, that is the answer here. And reminder that we have meters and we have hours. So we need to have it after our speed calculation, meters per hour. So that is his average speed, okay? All righty. Moving forward, this is a chain of terms activity. So you're going to try to work on this one and this slide, and we will go back over these two in person. I'm not going to do it in the video because I want to get through some more slides here. But you're going to complete the puzzle on the right by solving the practice problem that says start. Okay, so practice problem, you're going to click and drag the orange box with the correct answer directly below the practice problem. So this is the practice problem, and you're pretty much like the answer. You're going to drag it under here, okay? Then you have the box with the correct answer also contains a problem. Continue to solve the practice problems until all the boxes are used and you have reached the end of the puzzle. So pretty much like this is the start, and you're putting these in order to get to the end. Okay. So pretty much this last one's like, congrats, you've solved the puzzle. So you're trying to putting these in order to get to the end. All right. So we're going to move forward from there. You're going to look at each graph and read the questions that follow. So we're going to do this one together, and then you're going to do this one by yourself, okay? So find the correct answer, including the label below, and match it with the graph. So what is the average speed of the boat between 4 and 6 minutes from this graph? So we have average speed of the boat, all right? We on the bottom again is time. On the side over here is distance. So we know we have a port of origin, and you can see from us going over, we were like constant speed, it's less, greater, you know what I mean? At least we know they're traveling. So between 4 and 6 minutes. So we have right here the time. What is the average speed between 4 and 6 minutes? So about what, 5? Okay. So up here, about 5. And then we're looking at that dot. So we can do 5 minutes divided by what is there. So 500 to 1,000, 600, 700, 800, 900. Okay, so this is about 6, 7, 8. This is about 800 meters. So we have, let's pull out our calculator again. We have 5 minutes divided by 800 meters. And it says the 0.0, oh, whoops, I did that totally wrong. We need to do distance divided by time. So this is a good point to notice that if you ever type it in wrong, when you have a multiple choice answer, your answer won't be listed there. So this is kind of good for you to even realize that these are multiple choice and I'm picking the right one for this answer. Obviously, the answer choice was not going to be there. So heads up, maybe go back and rethink what you typed in. And obviously, I typed it in wrong. So that's my bad. So 800, because we need to do distance first, divided by time. And that would be 5. And then we get 160. So the answer closest to 160 would, oh, let me get out of here, back, would be about meters per minutes. Okay. There we go. We need, a lot of you would look at that one because you saw it first, but it's going to be this one, about meters per minute. Sorry, that popped up. So we're going to put that one there. Now you go ahead and do this one at 4 seconds. So we need to get you set up. This is 4 seconds. So go up to whatever it is at. So there you go. Okay, so you do 40 divided by 4. So 40 divided by 4 is what? Hopefully you know it's 10, but reminder, there's 2 10s. We need to use the correct units of measurement, seconds and then meters. So we have seconds and meters right here. Okay, there you go. So that's that one. Moving forward, again, this is just reiterating a practice problem. So we have speed of a car in 2 timed trials. What is the average speed during the 2 trials to the nearest tenth? Okay, so during the 2 trials, trial 1 and trial 2. So obviously it says during the 2 trials. So we need to add up both trials. So when we're doing this in maybe a lab and I ask for the total distance and total time, you got to add up everything. So using the pen again, I'm going to switch the color for this. We need to get the total of both distance and time. So you can see that on top is distance. So we need to add up this one and this one for trial 2. And we're going to get a total, and you can even punch that in a calculator, but it's 12.6. Then our times are 3 and 6. So 3 plus 6 is 9 seconds because we do have seconds and meters according to the chart. And when you go and type this in on a calculator, 12.6 divided by 9, all right, 1.4, and that would be your answer, okay? 1.4, but make sure you notice it's meters per second, all righty? So that's that. So study the graph below. What does it represent? Explain the reasoning. Well, thinking about it, if you guys remember when I went over the slide that looks like this, there's no speed. Okay, so if you have a graph that looks like this, time doesn't stop. Time increases, but you can see their distance didn't do anything. So as time is increasing, their distance is staying the same, meaning they're at rest. Whether someone's traveling and they stop for lunch or whatever the case is, they are at rest. Okay? So type something in along the lines of what we just said, that there's no speed. There's nothing going on here. Okay? They're at rest. So velocity. Velocity is speed in a given direction. So if you ever hear a commentator on a sports cast or something talk about the pitcher's velocity, you have to remember that speed in a given direction. They're pitching to that batter, to that catcher's mitt. That speed in a given direction. Same thing with this motorcyclist, speed in a given direction. Same thing with race car drivers, speed in a different given direction. So what do we need to know in order to find velocity? When you hear the word velocity, if I'm telling you it's speed in a given direction, what do we need to know? Type in what you think. Okay, so the velocity formula Again, I'll write these on the board for you, but it's the same as speed with a direction added. Okay, so it's speed equals distance divided by time, just with a certain direction added. Okay, so again, speed equals distance divided by time, but we're gonna do like a certain direction. All right, so it's like miles per hour north. So you might have like miles per hour, but you just have to add the direction in your answer. Okay. So that's really it. Give a real life example of something that is measured in velocity units. Well, we just went over some. I mean, there's one in the picture here. There's like a roller coaster that's going in a certain direction. Okay. You would be like that roller coaster, certain velocity in that certain area of it. So moving on to this practice problem, and this will be one of the last things I do in the video, maybe these two slides, and then we'll be done. Okay. So, distance divided by time, again, but in a certain direction. So, Jane and her mother take a trip from Houston, Texas to San Antonio, California. It takes them 25 hours to make the 1,400 or 1,400 mile trip. What was their velocity? Well, we take the distance. So, I'm going to change to pink. We take that distance, okay, which they did right here. And then I went over it, but it's a 25-mile-an-hour trip or 25-hour trip. San Antonio to San Francisco. They are traveling west. And you don't really need to know that. You can always ask me and I'll help you with the direction. But we know from like here pretty much to California is west. We're traveling west. So you really just do distance divided by time, punch it into a calculator, and you will get 56 miles per hour. But you have to add the direction if I ask you the velocity. So it's west. Okay. So 56 miles per hour, or you could write miles/hour and then west. Alrighty. Nice. Next one, average speed. So using the graph, how can you tell when the velocity has changed direction? Well, you can see this arrow's going up, then it goes down. Okay, so like you would just say like, like you can see on a graph it's going up, then all of a sudden it goes down. That's changing direction. So a diagonal line going up indicates velocity in one direction. Diagonal line going down, this arrow right here, is velocity in another direction. Okay. So we'll either continue here or you could try to continue with the rest of your notes if you have time. But kind of just see what you can complete. But that's pretty much it for today.